Now, previously we talked about how does a bond form. Okay, so if you can remember well, we said that bond formation consists of you having two atoms that are far away and then that are slowly approaching each other. And as they're approaching each other, remember we said the main thing there is that their energy is decreasing until the lowest energy possible, which means that they will have released enough energy to form a bond and they are stable. And then after that, because they are close to one another, repulsion forces start to become high, and therefore now that's why the energy increases there of the system. So here what we have is a graph of potential energy versus distance between two atoms of oxygen. Now, as you can see there, this is curve A, curve B, okay, and then 2.2.1, define the term bond energy. What would you say is bond energy? Is anyone who knows what is bond energy? Bond energy? Anyone? Okay. Um. Yes, sure. You can give it a try. Amount of energy required to break apart a compound into its own elements. Yes, yeah. That's very much correct there. That's very much correct. And if I may ask, do you guys have were you given the list of definitions from school? Because I believe for grade 11 there should be definitions that we yeah that you're given at school that you use. Were you guys given the list of definitions? Can you please confirm with me? So sorry. Is it okay? Is it who's saying they got them? Mr. Kevin, you have them because I remember. Yes, yes. I remember. Yeah, at Glen Vista they issue out those, so it's good. It's good. We do need these definitions, guys. Because these are the ones that are used by all grade 11s out there. Okay. But other than that, but I'll just check them. I was trying to check right now if I have. Um, I will try to check and then I will send them to you guys. Okay. Let me just do this. Um, so bond energy is the amount of energy that you're gonna release to form a bond. A bond. It's the amount of energy we release to form a bond. And then next question there. So I just I will find just a nice definition from a list of definitions, and then we'll write it here. So right now, just know that bond energy is the amount of energy that is released to form a bond. And then which curve A or B represents the formation of the double bond OO between the oxygen atoms? Briefly explain the answer. So, which curve there do you think is the one that represents the formation of the double bond OO? Especially now that I know some of you did Lewis structures, so you know what is a double bond. So, which one do you think is representing the double bond there? Which one? Anyone, guys? Think of it. B. Okay. Let's start with the one who says it's A. Why do you think it's A? If I may ask. Why do you think it's A? Or rather, what motivates your answer then? Okay, I hardly can hear you. I think I'm hearing energy, but I can't really hear what, what are you saying about the energy? And then what about B? Why are you saying it's B? If you're saying it's B, why B? Hmm, I see. Um, so understand the following, right? We have what we call bond length and bond energy, right? So there is what we call bond length and bond energy. Now, the proper definition for bond energy, please do write it down somewhere. Um, so this is energy released when bonds or molecules are formed. When bonds or molecules, when bonds or molecules are formed. Okay, that is what we call bond energy. Whereas now bond length is the distance. This is the distance between two nuclei in bonded molecules. Or yeah. So this is the distance between nuclei in bonded molecules. That is bond length. Then we have bond energy. So when atom A bonds with atom B, the nuclei overlap. I mean the outermost energy levels, they overlap. They overlap. Now since they overlap now, the energy that they released so that they can form this bond is called the bond energy, and it's represented by this part here. This is the bond energy for A, and then this is the bond energy for B. For B, that means it's minus 142 kilojoules per mole. This one is around minus 494 kilojoules per mole. That minus just tells us that it is energy released. That's why it's minus. But otherwise, energy is simply that one there. So now that we understand what is bond energy, what is bond length? Remember, bond length is the distance now between the two nuclei. So if we check the distance here between the two nucleuses or nuclei for plural, right? That is called the bond length there. Right. So That is our bond length. Now, understanding of bond length there visually, it's okay. But then now, how do we see bond length on a diagram? Well, to see bond length, we just check the bond was formed, the bond energy is here, right? So the bond length will be from here all the way to there. That is the distance between the nuclei. It's called the bond length. And this is the bond length for A. Now, what is the bond length for B? Look at the bond length for B. It is, which one is greater between the bond length of A and the bond length of B? Which one do you think is greater then? Right, the bond length for B is greater. Now, if the bond length for B is greater, what does it tell you about the strength of the bond? Which one now is going to have a stronger bond compared to the other? The longer bond length or the shorter bond length? Exactly, that's correct. The shorter bond length, the shorter the bond length is, the stronger is the bond. Okay, so that is why the answer here should be A, right? So that is why for 2.2.2 the answer will be A, because A has the shortest bond, it has a shorter bond length compared to B. Yes. Yes, ma'am. Okay. Mm. All right, can you just repeat it for me one last time? Mm. 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 Mm-hmm. So what you just described, it's you just described bond. You just described the point whereby we're saying they're stable here. You just described, yes, you just described for us the point where they're stable, whereby there is no forces of attraction or repulsion which are greater than the other, because they are stable at that moment, right? Even though we know as time goes on, the forces of repulsion are going to start to become dominant. So you explained to us that that is the lowest energy point, which is true. But then now it doesn't still give us sufficient reason as to why we can say this lowest point of A represents the double bond for oxygen, and this one is representing the single bond for oxygen. You see? Or yes. So but here when you're yes. Right. The shorter the bond length, I'm gonna write it here. So the shorter the bond length, um, the bond length, the stronger the bond. The stronger the bond. Hence, curve A represents the double bond O, because that is a stronger bond. then the other one will represent a weaker bond. A bond. So the stronger bond there is the one that um, releases the most energy, right? And another thing we should take note is that as bond length increase, this is just as part of your notes. Yeah. Please note that as bond length increase, just like in B there, right? Yeah, as bond length increase, then the bond energy decreases. Okay, so meaning the longer the bond length, the lesser the amount of energy that is released, or when the lesser the amount of energy that is released, meaning the lesser is the bond energy. And that would mean that that type of bond is not a strong bond, because for example, it's more of like what is holding you together is not strong, because no, it's not a lot of things. It's like two people who have maybe married or in a relationship on the basis that maybe you know, you like jokes, and then me and I like jokes, and then maybe you know, your beauty, and then you know, like they have few characteristics, few things that are in common. These are these ones here. There are few things that are in common, so that means um they don't have to sacrifice a lot when they form a bond. However, because they don't have a lot in common, it's easy to break that bond. So similarly here, if they release just a small amount of energy to form a bond, then it's easy to break that bond. But if they release a lot of energy to form a bond, then it's much difficult to break that bond. Is it clear, guys? Okay, perfect. Then they say now, write down the bond length of the bond represented by curve B. So yeah, I think we can see it there. It's what, 148, but check the units. It's picometers. Nay, it's PM, which is for picometers. We use picometers. Picometers. Right. So I hope that was clear. That was just so that you know how to interpret these curves. So if you are seeing them, just know that. And when you're explaining, in all of your explanations, make sure you include bond length and you include bond energy. In that way, you'll be guaranteed that you have marks. Right. So now today we're gonna continue right with that discussion of chemistry. But then we are gonna look at the different types of, maybe before we, yeah, maybe the type of bonds that we have, and also we're gonna discuss what the Lewis structures, ne? So we've already defined what is bond energy and bond length. We've explained the relationship between bond energy and bond length, and then the relationship between strength of a chemical bond and bond length, size of bonded atoms, and the likes. So these are some of the things we're supposed to cover in week 8, just before you finish off with chemistry. But it's just that it's still a lot of chem, but then hopefully we'll be able to do a lot and finish on time. So let's talk Lewis structures, or Lewis diagrams. Now, Lewis structures, these are used to represent bonds, right? So these are diagrams used to represent bonds. These are diagrams used to represent chemical bonds. Diagrams used to represent chemical bonds. Now, what is very important about these diagrams is that they only show the valence electrons. Okay, they only show the valence electrons. Now, which ones are valence electrons? Remember that valence electrons are the electrons in the outermost energy level. Electrons in the outermost energy level, meaning in the last energy level. So remember that when these atoms bond, they are only using, sharing, or donating or receiving valence electrons, not the core electrons. They're only dealing with the valence electrons. For example, lithium, if we check lithium, it has 3 and then 7 as the mass number. So this 3 tells us that lithium has 3 protons and 3 electrons. Now if we were to draw the structure for lithium, that means we'll have 3 protons here, by the way, and then we'll have 4 neutrons inside. So 4 neutrons. This is the nucleus. And then outside, first energy level outside here, you're gonna have an electron, 1, and then 2. This is the s orbital, and then is the 1s orbital, and then the 2s orbital has 1 electron. Right, so this is how lithium is in terms of its structure. It has 3 electrons. Now, how many valence electrons does it have? Right, if you check, the valence electrons are the electrons in the last energy level, which is 1. So it is only 1. Then how many core electrons does it have? Which means those that are not the valence electrons, they are 2. Okay, so using your periodic table, guys, you can actually tell how many valence electrons you have in a compound, in an element. So I'm quickly gonna show you that, so that you know how to use your periodic table there. It's a very, very useful tool that you have to use in order to excel in chemistry. I'm not gonna take all, I'll just take a part of it. So here's a periodic table here, the one that we'll be using in your exams. Now immediately you get this periodic table, please guys, I need you to make sure that you write here 1 plus, 1 plus, and then here 2 plus, and then here write 3 plus, and then here plus or minus 4, and then here write 3 minus, 2 minus, 1 minus, or you can say minus 1 minus 2 minus 3. In fact, it's much better if you write it that way. So you can also just say, in fact, plus 1 plus 2, and then you go here, you say plus 3. Here is plus or minus 4, here is minus 3, minus 2, minus 1, 0. What I just wrote for you there, it's called valency. Okay, it's called valency. And that valency there, I think that one is gonna assist you, in fact, when you are dealing with electrochemistry. But for now, guys, the valency will assist you why do you have compounds as they are. For example, why do we have H2O? How does it form H2O? When I combine hydrogen and oxygen, why does it give me H2O? Is there anyone who can tell me why? Unfortunately, lone pairs, they don't form a bond. They don't really form a bond. Mm-hmm. Anyone who can explain to me how does it form H2O? Okay. The reason why we have H2O, good people, is because this is what I teach my grade 9s. Guys, you must go to grade 9. Whoever was teaching you NS, you must tell them I want my change. Yeah. Right. So hydrogen is plus one, and then oxygen, right? Because it's in this group, all of them is plus one. In this group, all of them is plus two. And when you check oxygen, it is in this group whereby it's minus 2. So oxygen is minus 2. Now you only take the number. This 2 goes here, this 1 goes there. So that's why it forms H2O. The 1, we don't really write it. Just like in maths, you don't write 1x, you just write x. So that's why it's H2O. How do we form HCl? Why do we form HCl? Hydrogen is plus 1. Chlorine, look at chlorine, it's minus 1. Now you will have 1 and then you will have 1. So therefore, that's why we form HCl. Ne. So that is how we do it there. Let's see. How do we form CO2, carbon dioxide? Why do we form CO2? Well, carbon is 4, oxygen is minus 2. So the 2 is gonna come here and then the 4 is gonna come there. So therefore you will have C2O4. This is what you will have, right? You will have C2O4. Then because you have a common factor, you know, you divide by 2, divide by 2. Therefore that's why you have CO2. So that's where carbon dioxide comes from. Guys, you have to understand why do we have those compounds, you understand, or those molecules. Okay, so if I tell you right now to say, um, what compound am I gonna form if I combine, let's say, if I combine hydrogen and fluorine, right? If I combine hydrogen and fluorine, you must be able to say, no, because we're talking about hydrogen, it is plus 1, fluorine is minus 1. The 1 comes here and then the other one comes there, so you'll have HF. That's hydrogen fluoride, right? And remember, these ones, once they are inside of the compound, the last name puts, it has IDE. For example, if I have magnesium and oxygen, I'm gonna form, this is 2 plus and then this is 2 minus, or minus 2 and plus 2. So therefore if we do that method, you're gonna have Mg2O2. The common factor is 2, so therefore the answer simply becomes MgO. When we name this, it's called magnesium oxide. If lithium combines with oxygen, we call it lithium oxide. If potassium combines with oxygen, you call it potassium oxide. You understand? And then what about fluorine? Anything that will combine with fluorine will be called fluoride. For example, HF is called hydrogen fluoride. LiF is called lithium fluoride. NaF is called sodium fluoride. And then chlorine is gonna be chloride. Bromine is gonna be bromide. Iodine is going to be iodide. Yeah, so that is just the naming, guys, that we did back in grade 10, just so that you understand why are we naming these compounds in that way. But then now, the most important thing I wanted us to look at here, right, was not really the naming of compounds, was the understanding of how many valence electrons you're gonna be having. Now I want you to understand that these ones that are in group, you see these numbers, these Roman letters, 1, 2, 3, 4, 5, 6, 7, 8. I hope you can read in Roman numbers, guys. This is 1, this is 2, this is 3, this is 4, this is 5, right? You understand? Those Roman letters, they tell you the number of valence electrons that are in that group. Hydrogen this is 1 here, right? It means hydrogen, when you draw it, hydrogen has only one valence electron. This means it's gonna have a nucleus, and then it's gonna have only one valence electron, meaning the electron in the outermost energy level. Beryllium is gonna have two valence electrons. So this is gonna assist us in terms of drawing the Lewis structures. For example, when I draw the Lewis structure of hydrogen, I'm gonna say hydrogen, then I put a dot to show that hydrogen has what? Has one valence electron. Alright, has one valence electron. I can use a dot or I can use a cross. You can use dots or crosses, just a small cross. And this dot, you can put it anywhere. You can either put it here, or if you want, you can put it here, or if you want, you can put it there. Even the cross, the same thing. You can put it there, or if you want, you can put it there, or if you want, you can put it here. Okay, so this is how we then draw the Lewis structures. Now, how do we draw the Lewis structure for beryllium? Beryllium, it is two valence electrons, and here it's two valence electrons. So remember, these numbers, they tell you the valence electrons of the element or atom. So beryllium, you're gonna say 1 2. Guys, you're not gonna count like this. You're not gonna say 1 2. You're gonna count clockwise. 1 2. If we decide to use crosses, you're gonna say 1 2. These two numbers, they represent that you have two valence electrons. What about carbon? Carbon has 1 2 3 4. How do I know that it has 4? Because the letter here for carbon, the letter here is 4. It means all of them that are here, they have 4 valence electrons. What about nitrogen? Well, for nitrogen, it's gonna be 1 2 3 4. Then I come back 5. You see, I'm counting clockwise. Okay, and how do I know it as 5? This is because this is the V. All of them, they have 5 in here. Okay, so an exception is on helium. You can't say helium has 8. Ne? Helium has only 2 valence electrons, meaning when you write for helium, it's gonna be 1 2, and it's fine. Ne? And usually for helium, we show it like this. We show it as a, as a double bond. We show it like this. Not as a double bond, I mean as a lone pair. Right, you understand lone pair as we go, right, and the likes. Okay, so guys, yeah, for helium, no, it's not wrong, still fine. Okay, but know that for helium, those two, it is stable with those two. It doesn't need any other. Well, for neon, argon, is it kryptonine, and then this one, all of them, they're gonna have 8 8 8, these ones, because the Roman figure there is 8. So now that we know how to tell the number of valence electron that something has, yeah, it's a beautiful thing. So what do you think? How do you think I'm gonna write aluminium? How many valence electrons does aluminium have? 3. Perfect. Roman figure 3 there. So it will be 1 2 3. Beautiful. What about phosphorus? Five. Okay, perfect. 1 2 3 4 5. What about copper? Yeah. Copper is this one, say It's this one here. This one. Go and research it. Ne? Must go and research it. But you it will actually surprise you there. But it's fine, guys. That is how you find the number of valence electrons. Now, you also have to know how to represent what we call a you must know how to represent covalent bonds, and then you must also know how to represent ionic bonds using Lewis structures. Ne? So we also did this in grade 10, but then it's fine. How do we represent covalent bonds? Covalent bond, what is a covalent bond? This is a bond between a non-metal plus a non-metal. Okay, that is what we call a covalent bond. A non-metal and a non-metal bonded together. Now, how do we write? So now we're gonna write bonds of, we're gonna show Lewis structures for compounds or molecules such as H2O. How do we show this in terms of Lewis structures? Now the thing is that you're gonna look at the two elements, ne? Then you're gonna check. Normally, if there are three, your central atom is the one with the lowest electronegativity. But if there are two, you just have to figure out which one to start with. For oxygen, how many valence electrons does oxygen have? 6. So we say 1, 2, 3, 4, 5, 6. That's good. Now it's bonded to 2 hydrogens. As you can see, H2 means it's bonded to 2 hydrogens. Now the first hydrogen is gonna come here. Remember, a hydrogen has 1 valence electron. So now this valence electron can be shared with the one for oxygen to make a stable bond. So it shares with the oxygen, then the other one comes here and shares with the oxygen because it's 2 hydrogens. So it shares with the oxygen. Okay. So actually let me write it like this, and then let me write hydrogen here. So guys, what they just did here is to form a bond. This is a bond, this is a bond. Okay, those are bonds there. Those are bonds, that green part. Okay, so now if it is only one pair like this, it's a single bond. So how you write it is that you write oxygen here and then you write hydrogen there. So this structure here shows you it shows you the Lewis diagram for H2O. That is the Lewis diagram for H2O. And yeah, if you just know it, guys, you'll be okay in the exam because they don't change these diagrams. I'm not saying memorize them, but just know them. Right, so that is H2O there. Right, next one. How about CH4? What about CH4? How do we show the Lewis structure for CH4? Well, let's remember that carbon is gonna have how many? It's gonna have 4 valence electrons. 1, 2, 3, 4. Then it's bonded to 4 hydrogens. Where are those hydrogens gonna go? The first hydrogen comes here and then they form a bond. The other one comes here, then they form a bond. The other one comes here, they form a bond. The other one comes here, they form a bond. So therefore, right, this will be written as C bonded to H, bonded to H, bonded to H, and then bonded to H. So that is the structure of CH4, which is called methane. It's called methane. Okay, it's an alkane, and then you're gonna learn more about alkanes in grade 12. But then just understand right now that for CH4, that's how we represent it. Okay, right. Let's try others here just to have more practice, because they're a bit of a lot, these things. So let's talk about NH3. How do we draw a Lewis structure? The question will tell you, draw a Lewis structure or Lewis diagram for NH3. So now you're gonna check, okay, nitrogen has how many valence electrons? 1, 2, 3, 4, 5. And therefore the first H is gonna come there, the second H will be here, the other H will be there. So therefore this, when you write it, it will be N bonded to H, bonded to H, and then bonded to H. So that is the Lewis diagram for NH3 there. If you want, you can yeah. the atom the atom that doesn't have a number to it. Most of the times, ne? Most of the times. But how it actually works is that you look at electronegativities. It's just that because you have hydrogen, hydrogen will always surround. And get hydrogen has only one valence electron. So hydrogen, it is in its nature to always surround the other atoms. Are we clear? For example, let's look at H2. What about the Lewis structure for H2? This means you have two hydrogens. Well, the first hydrogen will be this one, and then the second one comes here, then they form a bond, then you have formed H2. You see? So that's how to show that. What about O2? O2 means two oxygens, right? So the first oxygen is gonna be 1, 2, 3, 4, 5, 6. Then the second one also is gonna have 1, 2, 3, 4, 5, 6. Now how are they going to form a bond, those two things? It's like you are trying to put two women who don't wanna get married or share you in the same household. So here, how can you how do you make these things bond? You see, now it's gonna be a bit of a challenge, ne? So how can we draw the structure there? Do you have any idea of what we can do? Mm-hmm. Exactly. They are gonna become so this one here, right? What will happen is that it's gonna come. They're gonna come closer together, and then similarly, these ones are also gonna come closer together like this. And once they've come closer together, the whole molecule, we can now shift it like this, right? And then it's gonna join the other one there like this. Then they formed a bond, but that bond is gonna be one pair and then another pair. Okay, so therefore we'll have formed a oxygen double bond O, which is the one we looked at when we started there. Okay, so that's how it forms that bond. So the ones that didn't have partners, they just come closer together. It's quite important to remember that. Yeah. Right. What about nitrogen N2? You know that nitrogen is 1, 2, 3, 4, 5. You know that the second nitrogen will also be 1, 2, 3, 4, 5. But then now, how do they form a bond here? Any idea? What do you mean, sir? No, that's correct, sir. The ones without pairs, they will merge together. So this one comes here closer to this one, and even this one comes here closer to this one. Similarly, that's what happens this side. That's what happens this side. So now that they would be like this one now comes closer to that. Then now they can form their bond pairs. First pair, second pair, third pair. So therefore, N2 is N triple bond N. So this is called a triple bond. And then this one here is called a double bond. A double bond. Okay, so I hope we are learning in terms of these ones that is N2 and the likes. Those are called diatomic molecules, ne? And they are exactly the same ones I circled here. Okay, so when you write nitrogen, nitrogen it occurs as a diatomic molecule, meaning it occurs as N2, oxygen occurs as O2, fluorine occurs as F2, Cl2, Br2, I2. And now you know how to represent their Lewis structures. Okay, now let's go to the ones that are a bit more challenging. What if we want to represent HOCl? HOCl. How do you think these things are going to look like in terms of the Lewis diagram? Now here is where you need to look at the one with the lowest energy lowest electronegativity. Now if we check here, right, the electronegativity shown on the left here as they point out to you. So hydrogen has hydrogen has 2,1. Oxygen has 3,5. Oxygen has 3,5 and chlorine has 3,0. So between those, which one has the lowest energy level? Hydrogen. Right, hydrogen. Which one has the highest energy level? Oxygen. Good. So, right, those with lowest, they will be surrounding. Then the one with the highest is going to be in the middle. The one with the highest energy level will be in the middle. So the one with the highest, you said it is oxygen with 3,5. So you write here, oxygen is 1, 2, 3, 4, 5, 6, isn't it? So it's going to be your central atom. It's going to be your central atom because it has the highest energy level. Then now chlorine, remember chlorine, it has how many valence electrons? It has 7. So when you write chlorine, you're gonna say that chlorine is gonna come here and it's one pair that is it's gonna join with that, and then it has 1, 2, 3, 4, 5, 6, and then the seventh one is the one that will form a bond here. Whereas hydrogen will come this side and then it forms. Is it is it just now, or can you hear me though? Okay guys, are you able to hear me? Are you there, Mr. Kevin?